The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has managed to observe places that are around 13 billion light-years away. But recently, James Webb has outdone itself. It spotted something it wasn't supposed to see. Astronomers using the telescope have detected a supermassive black hole from when our universe was less than 600 million years old. Just a baby. This discovery is the most distant, actively feeding supermassive black ever observed. It's located at the heart of its host galaxy, designated Sears 1019. The black hole is also one of the smallest and least massive ones found in the early universe. It's equal to approximately 9 million suns. It might seem like a lot, but in reality, supermassive black holes often grow to billions of times the mass of our star. But what is so unusual about this find, and why are scientists having a hard time trying to explain it? You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. It happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.5 million times the mass of our sun, are supposed to be seen in the more recent universe. Well, to tell you the truth, scientists have long suspected that supermassive black holes could have existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It has shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust falling inside them. Such swirls are also called accretion disks. The gravitational force of a black hole heats this matter, which makes the disk shine bright like a diamond. Sorry, but that's not all. Strong magnetic fields produced in the process channel the matter to the poles of the black hole, and from time to time this matter is blasted out of there in twin powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. By the way, astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Synth survey. They saw the galaxy as it was when the universe, which is around 13.8 billion years old now, was a mere 570 million years old. Besides the main character of this video, scientists spotted two other black holes. Those probably appeared 1 in 1.1 billion years after the Big Bang, and 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. The coolest thing about all these discoveries is that until recently, all research about things that existed in the early universe was mostly theoretical. But now, with the help of the James Webb Telescope, astronomers can not only see galaxies and black holes at unimaginable distances, but they can also measure them. This isn't the only discovery connected with black holes made recently. For example, not so long ago, scientists saw two stars slow down in their orbits around black holes, and concluded it was most likely the result of drag produced by dark matter. It was the first time astronomers might have discovered some indirect evidence that huge amounts of dark matter could surround black holes. Now, about that dark matter. What is it, and what does it consist of? Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Since it's such a small fraction of the universe, maybe we shouldn't call it normal? Dark energy takes up around 68%, and about 27% of the universe is dark matter. This dark matter is just one more space thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. This matter is dark, so we can rule out visible stars and planets. It also can't be dark clouds of normal matter. Otherwise, scientists would be able to detect it. Dark matter is not antimatter, since astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. In other words, dark matter is still as much of a mystery to us as dark energy. Anyway, back to the potential dark matter discovered around the black holes. If it is confirmed, it'll be a great breakthrough in dark matter research. What helped scientists come up with this idea is that dark matter interacts gravitationally, influencing ordinary matter. So, a team of researchers watched the orbits of two stars decay by about 1 millisecond per year, while they were circling their companion black holes. The scientists concluded that these changes in speed were the result of dark matter generating friction and a drag on the stars. With the help of computer simulations of the black hole systems, the team tested a model widely known in cosmology. It's called the dark matter dynamic friction model, and it predicts a certain loss of momentum by objects that are gravitationally interacting with dark matter. And guess what? The simulation matched these predictions. The results of this research helped to confirm a theory that had existed for a long time, that black holes can actually swallow dark matter that comes too close. As a result, dark matter gets redistributed around black holes, creating areas with different densities, which can influence the orbits of surrounding objects, like the stars we've been talking about. Speaking of black holes, there's a theory that primordial black holes could actually be dark matter. This type of black hole is hypothetical since scientists have never got any real proof of their existence. Such holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. If primordial black holes indeed existed, they could appear because in some regions of space, it was hotter, other regions were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though, these holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. Anyway, the idea of the connection between primordial black holes and dark matter, or rather, the idea of them being the same thing, remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think, and it means that the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching.